Do you know who is Galileo Galilei? I know we are familiar with his name, but do we know what makes him known for? Galileo Galilei. Galileo Galilei was an Italian scientist and a philosopher. He was born on February 15, 1564 in Pisa, Italy. He is a scientist who helped in opening the eyes of the world to a new way of thinking in the field of astronomy. He was known for his groundbreaking discoveries using a telescope. And one of his discoveries is the phases of Venus and also the moons of Jupiter. His support for the heliocentric model of the solar system led to his condemnation by the Catholic Church. But despite this, he still continued to make significant contributions to science. This includes the development of the laws of motion and the principles of relativity, wherein ito yung mga pinag-aaralan natin in other subjects, like for example in science or even in physics. That is why Galileo's life story is one of the examples of perseverance and dedication to pursue knowledge. But the idea for the telescope came by the way of a Dutchman named Hans Lippershey, who applied for a patent on the invention in 1608. In other words, Hans Lippershey is the inventor of the telescope. And while Galileo got a lot of things in his empirical observations of the night sky, he also had a few notable misses. One of it is when he postulated that the tidal motion of the seas was attributable solely to the rotation of the Earth on its axis, neglecting the factor of gravitational pull of the moon. Johannes Kepler is said to be the one who first described the moon's tidal pull, and the one who corrected Galileo's description of planetary orbits by pointing out that they were elliptical and not circular.
Galileo Canon has been hailed as the father of observational astronomy, the father of modern physics, the father of the scientific method, or as Albert Einstein famously noted, the father of modern science. Galileo's scientific work was not confined to any one area. He is best known for his astronomical observations, which included the features of the moon, the phases of Venus, four of Jupiter's moon, and the sunspots, as well as for the radical theories that flowed logically from those observations.
He was also a dedicated thinker, optimizing the telescope for military and then scientific use, as well as using geometric calculations to improve the accuracy of the decimalistic and military compasses. And he conducted rigorous experiments on objects and materials, carefully collecting data and subjecting that data to mathematical analysis in order to obtain objective and replicable results.
So by increasing its magnification and clarity, Galileo was able to observe celestial bodies in greater detail and make groundbreaking discoveries. For example, he observed the phases of Venus, which provided strong evidence for the heliocentric model of the solar system. He also discovered the four largest moons of Jupiter and the rings of Saturn, which revolutionized our understanding of the cosmos. Galileo's advancements in telescope technology not only led to significant discoveries in astronomy, but also paved the way for the development of modern optics and imaging technologies.
Through his empirical approach to obtaining and analyzing data, that Galileo can be seen to have pioneered the scientific method. Rather than seeking out evidence that would confirm and conform to a certain orthodoxy or ideology, Galileo aimed to arrive at whatever conclusions a careful analysis of evidence would suggest. Those conclusions then informed his theories, even if they contradicted established doctrine and convention. For example, one experiment Galileo never actually conducted, although he told his story to a biographer later in his life, involved dropping two cannonballs of different weights from atop of Tower of Pisa.
The point would have been to demonstrate that they would land at roughly the same time, directly contradicting the accepted Aristotelian notion that the rate at which objects fall is proportional to their weight. Galileo didn't have to drop cannonballs to prove the fallacy of Aristotelian physics. He'd already collected enough data from less perilous experiments to know the inevitable results. Galileo did not operate in a vacuum. The Polish astronomer Nicolaus Copernicus formulated a heliocentric model of the solar system in the early 16th century, and his ideas have been published in the treatise on the revolutions of the celestial spheres shortly before he died in 1543. Galileo built and perfected the telescope he used to observe the geography of the moon, phases of the Venus, and the moons of Jupiter.
But the idea for the telescope came by the way of a Dutchman named Hans Lippershey, who applied for a patent on the invention in 1608. In other words, Hans Lippershey is the inventor of the telescope. And while Galileo got a lot of things in his empirical observations of the night sky, he also had a few notable misses. One of it is when he postulated that the tidal motion of the seas was attributable solely to the rotation of the Earth on its axis, neglecting the factor of gravitational pull of the moon. Johannes Kepler is said to be the one who first described the moon's tidal pull, and the one who corrected Galileo's description of planetary orbits by pointing out that they were elliptical and not circular.
It's hard to pinpoint exactly when Galileo reached his revolutionary conclusion that the Sun, not the Earth, must be the center of the solar system, and that the heavenly perfection set forth by Aristotle and codified in the Ptolemaic system was fallacious. By most accounts, it was a cumulative process of discovery. His initial telescopic observations revealed the geographical features of the moon. He could then employ mathematical calculations to confirm what he would have already suspected regarding the true nature of the cosmos, and by 1609, he was synthesizing these evidence-based ideas in the text that would become Starry Messenger.
So Galileo's overarching contribution to modern science was his systematic development, implementation, and description of the scientific method built on evidence-based research. This he laid out most cogently and categorically in two books, 1623's The Second Saggiator or The Slayer, and the two New Sciences Discourse published in 1638. But his historical impact and legacy is bound up in his astronomical observations, the conclusions he drew from this, and the reaction of church authorities to the results.
Galileo was certainly aware of the perils of contradicting church doctrine. However, by the early 17th century, the messages coming from the church regarding scientific research were mixed. In 1953, the Dominican friar, mathematician, and astronomer Giordano Bruno was burned at stake on the orders of the Inquisition for the heretical crime of promoting ideas that ran counter to Ptolemaic geocentrism and thus church teachings.
Within certain sectors of the Catholicism, there had been a gradual acceptance of science and enlightenment. In 1582, under Pope Gregory XIII, the Catholic Church had adopted the Gregorian calendar, which used calculations based on the Copernican system. There was also an alternate cosmology based on the ideas of Danish nobleman Tycho Brahe, which had gained acceptance particularly among Jesuit clergy and intellectuals.
The Tychonic system was a compromise that blended elements of Copernican heliocentrism with traditional Ptolemaic geocentrism. It maintained the Earth as the fixed center of the cosmos, while conceding that 5 other known planets revolve around the Sun, arguing for the geometric benefits of the Copernican system and the philosophical or the theological advantages of the Ptolemaic system.